Hey, what's up, everybody? Welcome back to another Layer by Layer, the live streaming edition. That's right, streaming live from South Florida, broadcasting here in my room. We're going to do some 3D printing today, and we're going to actually start on a sort of a new project. We'll continue the Raspberry Pi Zero, Pi Girl Zero project probably on a Sunday, but today I just wanted to start on working on this new project in collaboration with Tony DeCola. So let me go through some of the screens here to make sure everything is okay. That's my desk bench here, workbench thing. This is the sort of prototype that I'm working on. I'll go over it in a little bit. And this one over here shows us what we're printing. Let me fix that real quick. So I'm actually printing some droney trophies. So if you guys haven't heard about that yet, go to adafruit.com/dronies, and you will see all the details for the contest. We actually sort of drafted it like a year ago, but we finally have awesome judges, and we're starting to take submissions. So be sure to check that out. And I'm just making trophies in the background using copper fill on the printer bot play there. Let's see, what is this screen? Oh, this just shows my Octoprint screen. Okay. So that's just Octoprint running in the background. I'll be maybe going back and forth momentarily depending on how the stream goes. But let's go ahead and talk about the project. So Tony DeCola got inspired by one of the new updates to Facebook. You guys know Facebook, right? They recently added some reaction emoticon things. So Tony thought it'd be kind of a cool idea if we did a physical version of it. So that's what this is here. This is a 5-volt Adafruit Trinket microcontroller, and this is the 14-segment LED display, but the project's actually going to use the 7-segment display. I don't have one on hand, so I do, however, have this one, and you can see it's not exactly working perfectly, but it kind of works. And if you click on the button, it's supposed to increment the count here. So imagine this being like a like count, and then when you click the button, it increases it when you like something. So you can put it up to whatever. I don't know, maybe like a work of art or something. So the weird thing about it is that I actually have to click it 10 times in order to get to the increment once, and that's just because this the sketch Tony wrote is specifically for the 7-segment display, and again, this is the 14-segment display. So I wired it up, and I was hopeful that this would work, and it kind of works. So the cool thing about this though is if you unplug the Trinket from the USB power and you plug it back in, it actually saves the number in the EEPROM. So that's a really cool way to do this. So if we take a look at this screen over here, whoa, let's go ahead and jump into the actual GitHub repo. So it's private at the moment, but it will be public as soon as Tony and myself put together the guide for it. My part of the project is really just to do the 3D printing part of it, make an enclosure for it. So here's a really quick description of it. It's a Trinket sketch to build a react or like button that counts the button presses and displays them on a 7-segment LED backpack. So again, here's the hardware, the Adafruit Trinket, the display, 7-segment version, and some sort of button. And he goes through some of the wiring here, some of the dependencies, the libraries, just 2 libraries, the GFX library and the LED backpack library. And it's pretty straightforward. So this is the one I'm using, which isn't the right one. Again, this is not the right one, but that's all I have on hand, so that's what I'm using. And then here's the right display. So this is the 0.56-inch 4-digit 7-segment display with I2C backpack. Okay, and these are actually some kind of older photos. So what I would do is usually I would take the tech dimensions and like start drawing it in CAD, but let's see what happens. So I'll open up the guide for it, the associated guide. And this one guide sort of encompasses all of the backpacks. We have quite a few different ones. We got an 8x8 matrix in 2 different sizes, the alphanumeric one that I'm using, the 7-segment one. This is the one that we're actually supposed to use. and it steps through some of the things like soldering the backpack in, or the LED in, how to wire it to an Arduino real quick. But there's no tech drawings. So if you go to downloads, this is usually where you would see them. For newer components, Lamar makes a nice little render with measurements and stuff out of EagleCAD. But I thought this would be a cool tutorial to show you guys how to use EagleCAD to sort of make some dimensions using the board files, board files, and then bringing those into Fusion 360 or any other CAD package. So if you click on the GitHub link, which is right here, schematics and PCB files available from GitHub. Yay, open source hardware. These are all the board files, so you can go ahead and download them here. There's a download zip file. So just about any component we give away our board files, which is awesome. Here's the trinket one, but we'll be focusing on the LED, the 7-segment display. So I already have that downloaded here, so this is what they all look like. And I'll go ahead and open it, just the board file. So it's the segment 1. Yeah, this one. So I'll open that. And what you can do, or actually let me close this because I've been modifying it. This is what we'll end up be doing. But let me close that and then open it up again. So this is what it looks like. You can download EagleCAD Lite. I'm using 7.0. And this is what it looks like. All this stuff is here, but there's no measurements, so that's what we're going to do. We're going to make some measurements. And this is just sort of an introduction to the user interface. Now, I don't know how to use every tool in here. I've only used it to the extent of making like a simple gamepad PCB like you guys saw on the Pi Girl 2. But I think this is good enough to, you can know enough to like open up a board file and then make some dimensions so you can use those inside of Fusion, something like Fusion 360. So let's get started. Just to move around, I use the middle mouse button to click and drag and move around, and then just scroll wheel to zoom in and stuff. Yeah, let me check to make sure like the stream is okay. Yep, looks okay. And I'll answer some questions in a little bit, but I want to get through this real quick. Okay, so the first thing I'm going to do is actually turn on the grid. I always like using a grid. I'm familiar with it on Fusion 360, so I like a grid. So I'm going to turn that on. The grid button is right over here. It looks like a grid. And right now it's turned off, so I'll turn that on. And right now everything is by inches, and I like to work in millimeters. So I can just change that by going to millimeters, and then the size of the sort of little squares that you would get in your grid, I'll just put 0.05, so that's half of a millimeter, and I'll hit OK. So you can see our grid is there, so that's kind of cool. And the next thing I'm going to do is I'm actually going to hide some layers. So there's actually a bunch of layers. There's like 200 plus layers, and I'm only going to show the layers that I kind of need in order to get these measurements. So what I'll do is I'll click on this button here. This has like, there you go. If you roll over it long enough, it'll tell you what it is, layer settings. So if you see, it says like number. Those are all the layer numbers, and then the name of the layer. So top, and then bottom, and a bunch of other layers. So if you deselect it by just clicking on that blue highlight and hit apply, you'll see it hide the layer in the canvas here. So I can just keep doing that until I get to somewhere where I kind of want. See this one, layer 20, because it says dimensions? I kind of want that because that's the actual outline of the board. So there's some other ones here. I'll deselect these, what happens? That gets rid of some more text and stuff. And I'll deselect all these, hit apply. Holes, layer 45, that's actually the holes here. So I'm going to leave those. I definitely want those. Document, reference, T-doc. I actually want to keep T-bottom because watch what happens when I hide it. It gets rid of the whole sort of outline for the LED display. So I kind of want that. So that's layer 52. I'll turn that on. And then there's some other ones here. V-score, not sure what it does. But that's okay. I just need what I need. I just need the minimal stuff here. So just a couple layers are turned on. And I'll hit OK. So now I have sort of just what I need in order to get some measurements going. So actually, if you wanted to be really sort of hasty about it and be like, yeah, I don't have to do measurements, I can just export this out as a DXF and then like import it into Fusion 360. You can totally do that, but there are some caveats that you need to be aware of. So I'll go ahead and do that. I'll export this out as a DXF. That's an Autodesk sort of file. And you can browse for it. And there's some options here. So like use a vector font, use wire widths, fill in the areas. You can read through all of them, but I'm just going to hit OK. And I actually already saved it out, so I'll just overwrite it and say OK. And now I have it saved. So I'll go into Fusion. This is actually some of the components I've already made for the project, like the arcade button, but whatever. Let me close this out. And close this out. Just to lighten the load and close that out. And now I'm working on a new document. Okay. So we'll start with the top here. I'm going to go up to, I'll close the data panel so I can get more icon, more real estate. And I'll come up here to insert, and I'll say insert DXF. And then I'll have to select the plane that I want to play on, and then select DXF file. I'll navigate to it. It's right there. I think that's the right one. Yeah, this is the second test one, so it's this one, latest one. So hit OK. And give it a second because it's gonna take a minute to calculate all the stuffs. And it imports it in with a scale factor of like 200 or something. It's too big. I know it's too big because I've already worked with it and tried this out, but you might not know that because it doesn't really tell you anything up front. There's some options here. You can do some distances. You can move it around, and you can turn off some layers. And you can say I want to do like one sketch per line, so that's like one layer per sketch. So you can make multiple. So this would be two sketches, and I guess that's okay. I'll hit OK on that so that it's not so crazy. And you can see that it imported a bunch of other stuff, and that's going to really bog down my machine particularly. So like just zooming in is going to be super slow. And I'll just hide layer 52 and reveal layer 20. And then I know this is supposed to be 2 millimeters because if I go into Eagle and I double click, if I click on the eye icon, this will let you get an inspector thing. So if I click on that, it'll say the drill hole size is 2 millimeters. So I know it needs to be 2 millimeters, but when I do a measurement here inside of Fusion, you'll see it's actually 20 millimeters. So right off the bat, we're working with wrong dimensions. So one thing you could do is you could of course scale it down, but there's some things to know about when you're scaling it down. So if I'm in the scale mode and I'm going to make a selection here and select all that. I can't do it that way. I have to select and in the browser here. And now I can do 0.01 because that's the scale factor I need. And then I'll hit OK. So now when I zoom into it and then do an inspection on the circle, you'll see it is 2 millimeters. Yay! So that's okay. But when I actually go into it, it actually reverts back to the original way. So the scaling is not doing it within the sketch mode. It's doing it outside of the sketch mode. So if I go in here and then do an eye, and you can see it's back to 20, and it's like, oh no, and it's really slow. I'm not sure why, but it's pretty damn slow. So it's weird working with it. You could of course work with this and then export it out, and then you're kind of good. But I wanted to show you guys the second way of how to do it. So that's one way to do it. You could do it this way and then just draw around it and stuff, but I find it really kind of slow for whatever reason. Even though it's like a simple sketch, it's incredibly slow. So one thing I'll do is I'll show you guys the second way. So I'm going to go ahead and delete this because there's not much to it else. Oh man, that's crazy. I'll try to delete all this. Ugh, don't crash. Delete everything. Just no more. Don't save. Go away. Okay, so I'm going to start back in Eagle, and then I'm going to show you how to use the dimension tools in Eagle, so you can just sort of draft out some of these. So the dimension tool is down here, and you just click on it, and right off the bat, like, oh no, the bottom layer, so layer 16 just popped up anywhere. That's okay. We'll hide it again, and I'm going to go on to layer 20 dimensions, And then I'll open up our layer thing again and just, you know, deselect that, apply, okay. And now when we draw on something, it'll be on that layer, on layer 20 dimensions. So the first thing I'll do is I'll do like a circle thing. So if I click on that, it tells me right away there's some options up here. These are all the different types of dimensions you can do. And you can change sizes and other cool things like that. But I'm going to leave it where I want, millimeters, and that size is fine. And this is just going to tell me what the radius of the circle is. So I know it's 2, but I don't want to do that. So what I do want to do, however, is I want to say, what's the distance between these two circles, these two mounting holes? So to do that, I'll just change the type to this guy over here. So now when I go click on this other part, click, now it tells me what the distance is between those holes. So it's 43.69. So I'll click on that.
You got static coming in.
Static? Like from this? Uh-oh. Alright guys, give me a minute.
I thought you were on batteries.
No. Let's do that. Okay, let's see if this is a little bit better. Does that sound better? I think it should sound okay. Yeah, sometimes my microphone gets a little bit staticky, so I just have to like restart it or whatever. I think it should be good. Let me see what everybody's saying. Go to this guy. Making some printing progress. And I'll just take this moment to look at the chat. Sounds all crackly. How's the sound now? Hopefully it's not all crackly. Yes, sounds good. Okay, cool. Well, thank you guys. I'm not monitoring my own audio because like there's a delay in when I use Wirecast. So I don't know. Thank you guys for like letting me know. But let's go ahead and jump back into the EagleCAD stuff. So back in EagleCAD. Okay, so I made my first dimension. That's cool. That's what the distance between those holes. And I'll go ahead and do the next one.
Yeah, you're good.
Okay, thanks. Yay. So the next one is going to be like, let's say this one to this one over here. Again, I have to change the dimension type because it defaults it to the radius. Or the is it the radius? No, it's the other thing. Okay, so that's the dimension from those two guys. And again, I'm just clicking in between those objects, those sketches. I guess we can call them sketches. So it's 22.86. And then you can also do things like the radius of something. So like the fillet here, if you want to know what that is, you can just click on it and it'll default to radius. You can see it is indeed going on that radius, and it's actually 2.54. I would have figured it's like 3 or something rounded, but no, it's actually 2.54 if you want to be exact about it. So those are the mounting holes. I know the distance between them. And the next thing I'll do is to get the sort of height and width of these guys, of the actual board itself. So to do that, I'll just click on this guy. From that to this guy. That's going to be 26.67. And then I'll do these guys over here from here to here. Maybe do it down here. I'm just using the same tool over and over again. So from here. Oops. Not sure what. Oh, there we go. It's a little bug or something. From that to over here. So that one's going to be 50.04. So that works cool. Okay, so that's pretty much all the things oh, the other thing we need to do is to figure out what is the width of these guys here. Like, what is this? Because that's basically the outline for our LCD, or LED, rather. So we can click. So watch what happens if I click on it. Yeah, same thing. So that's going to be 19. And that is pretty much all we need. So now we got everything we need to recreate it from scratch in Fusion. So yeah, we can. One other thing I want to note though is to check out this crosshair. This is basically the sort of center point of this whole thing. And to know that it's exactly in the center, you can do go to the little eye info icon, the info tool, inspector tool, I guess. And then we can click on some lines. So if I click on this line here, it'll actually tell me where it is from that center. So it's actually 25.95 millimeters on the X. And then this second column is Y. So that's 10.75 on the Y. So let's keep a track of this one, 25.019. If I go on the opposite end of that, it should be the same because it's in the center, right? So it is 25, but positive, right? 25.019. I'll hit OK. So now I know it's in the center here, and you can do the same for these two guys, the X and this line and this line. And I know it's in the center. So what I wanted to make sure that that's in the center. Now when I click on one of these holes, I can know what the distance is from the center. So I can figure out exactly where this first hole needs to be, and then I can just mirror it on the X and Y, and then everything should be fine. So I'm going to keep this open here. Or actually, let me close it, zoom out, because I'm going to do a little bit of back and forth when I draw this in Fusion. So let's go ahead and draw it in Fusion real quick. And it's pretty straightforward. I'll just make a rectangle, click on this guy here, and then wait a minute here. Okay, there it goes. I'm gonna do this center rectangle, so it's gonna be, so the center point will always be in the center, and I can draw out our rectangle. Let's just put in some whatever numbers, 'cause I already forgot what they are. I think this one's 50.04. Yep, and then this one is 2667. So let's do that. 2667. Okay. So that's our main board thing, and then I'll go ahead and do the circle. So it's just somewhere around here in this area. I'm not sure where, but I'm just going to draw it out. I know it's 2 millimeters in diameter. That's the one. Diameter, not radius. Diameter. I can just drag it out here. And now I can do a dimension saying from the center. So if I click on this point and then this point, you actually don't need a center line to figure out where you want to go. So if you just drag up, you can see it's actually the distance between the center is actually 20 from here to here. And that is the X. So when I go back and open that up, this is actually what it needs to be, 21.844. So I'm just going to paste that in. If it let me highlight it, there you go. Hit enter. And then I'll do again from the center, but this time I'll drag out this way. I'm not even like clicking and dragging, I'm just moving the mouse to drag, and then when I click, it'll set it there. And then that's going to be 1143. So copy that value, select this again, and then paste it, and then hit OK. And now I have my first hole. Now I know that this is all centered and stuff, now I can start doing a mirror. And now that's when you probably want to make some center lines, but that's easy to do. I just bring up the center line tool, and then draw it out. I don't even have to go all the way. It's just some sort of center. Oh, hit escape, because I need to make a new one. My machine is super slow, guys. And select these two guys and just hit X on my keyboard to make them construction lines. And then I can do a mirror. So I want that guy. This one. Okay, so that's my first mirror. And then I can do a second mirror. Right click. Repeat mirror. Click on these two guys. Pick my mirror line. This time it's going to be this guy, horizontal. Hit OK. And then I think the last thing I need to do, it didn't carry this one here. I wonder if I can double click it, edit that. Maybe I can edit it? No, probably not. Okay. So I missed one hole. That's okay. Let me repeat the mirror again. Okay, now I have 4 mounting holes. Okay, cool. And then the last thing I'll do is to get that this 19 here, which is sort of the height of our LED display. So I'll just do another rectangle, this time in the center, or actually the same in the center. Click it from the center. I know it's supposed to be 50.04, and then this one's going to be 19. So I'll just hit enter, and then I'll hit stop sketch. And there we go. We have something we can extrude from. So at this point we can, did I hit sketch? Stop sketch. There you go. So now we can extrude from this. So I can right click, make a marquee, hit E on my keyboard to extrude. And then the board thickness is about 1.6. So hit OK on that. And I forgot to deselect the holes, so I'll just double click on that feature, that extrude feature in the timeline, and then just hold down Command or Control on PC and deselect these circles. And hit OK. And then I can do some fancy stuff like the fillet. I think it's F on my keyboard, and just select the lines that I want to fillet. I could probably just do this. Select all those. I think it's 2.56, 2.54, and I forgot one. There we go. Okay. And then I can bring back the sketch and extrude the LCD screen thing. I'll probably do that on a separate solid so it's not combined, so I can kind of play with it a little bit. And I think it's like 8 or 9 millimeters tall. I'm actually going to change the operation to new body, and then I'll change the direction to two side so that it starts off by 1 point. Sometimes I can't change this, so I'll change it over here. 1.6. Okay, so now I have my 2 things. And I think that's as far as I'm going to go, because you guys can figure out, you can sketch on top of this and make a mounting bracket. And I'll just show you what I already did. I think it's Command Option P to bring back. Yeah, cool. So I already did this one. And this kind of shows the mounting tester bracket thing, and that's all it is. It's got a cutout for the screen, and it's got 4 standoffs and little pegs here, and this is pretty much the what we just made, but this is like an extra thing from it. I just like did a offset on the outside of the board so that it's like 2 millimeters away, offsetted from it. And that's all it is. I'm gonna get the parts. I believe they're shipping tomorrow, so I can test it out, because I actually already have printed this. And let me show that to you now. Over here, this is the little bracket guy. It looks a lot similar to all the other testing pieces that I have. Doesn't fit on this, on the alphanumeric display. It's like too big. The alpha display is too big, so it doesn't fit. But because it's not the right component. But anyway, I just wanted to share with you guys some progress that I'm making on this project, and sort of a sneak peek of it. And this is a little other tester bracket thing I made for the 5-volt trinket. But this is you can see that we actually had 2 different versions of it. They're both the same, but there's just the only differences. Well, there's a little bit more differences, but the major difference I think is these USB ports. This is like mini, and this is micro, and it's a lot smaller and more editable. You can eat it, and that's it. I pretty much for this one I just exported the DXF and sort of imported it into Illustrator and cleaned it up a bit, and that was all I did there. But yeah, pretty cool project, I think. Physical like button. If you guys like this one, I guess like it metaphysically, I think. And let's take a look at PrinterBot. So I'm at I don't know, like 25% or so. This is printing the column version. The trophy is in several different parts. Here's the head of it, kind of printed in copper fill. I still have to polish it and stuff, because that's what we're gonna do. And here are like two of the little arms. They like go in here, and then it's like that. And then there's like another half of his head that goes over here, and that has like a magnet on the bottom, so that magnetizes to the column that I'm printing. And then I have to update the base, because the base actually says 2015, and it's now 2016, so I have to update that. Okay, I'm gonna go over here and then take a look at the comments, see if you guys have any questions. Any questions, let me know. Sounds good. SpaceX rocket exploded my mic. Yes. Okay. I could just extract the whole pattern. Hopefully this is just like a little intro for you guys on how to sort of work around EagleCAD, because all of our board designs, Lamar's and K-Towns' board designs, are done in EagleCAD. So it goes a long way to learn a little bit of EagleCAD, at least enough to, you know, get some dimensions. I'm not an electrical engineer by any means. I'm a designer, but I get a kick out of being able to design in different mediums, especially Eagle, and I think it's pretty cool. I don't know there's so many tools and things, but you don't need to know everything if you just want to do a very specific thing. This is sort of my first time actually using Lamar's board files to make a component, because normally what I do is I just use calipers like these guys here, and that's all good and fine and everything, but it's really nice to just have everything exact. Like the mounting holes, like I would never have figured they're like, you know, this one here is 43.69. So I think it's cool that you can open these up, and EagleCAD's free, Fusion is free, so good stuff. Yeah, back to the printer. Okay, well guys, I think that's gonna be it. I just wanted this to be like a 30-minute stream or so, and I think we have covered everything, all the little points that I wanted to. You could either export stuff out as a DXF, or you could create some measurements on your own for your components and model little bracket things. But yeah, oh yeah, I forgot to mention I'm actually going to use this button, not this button, because this button's kind of small. And I also want to, of course, put an LED in there and actually put like a little heart or a thumbs up or whatever other emoticon thing, you know, you want to put in there, because this is actually fairly easy to I think. Can I take it apart? I've taken this apart before. There you go. So I really like these buttons because they're so slim. They have a great springy feel to them, and you can take it apart, and there's the actual button part. I don't know if you've seen me do a project with this, but I did like I 3D printed a holder for a NeoPixel, and just made a little diffuser NeoPixel holder and replaced this part basically. But yeah, this is the button I want to use, and I already modeled it in Fusion. But yeah, this is an awesome button. So that's all the components. Pretty simple project. It's not going to be battery powered. It's going to be, well, sort of battery powered. It's going to be USB powered, so that you can have it on your desk or something. But I don't know, pretty cool. That's it for this for today. I will try to do one on Sunday, continuing the Pie Girl Zero project, more the simple one. But thank you guys so much for watching. I really appreciate you guys spending some time over here. Happy Friday, everybody, and I hope you guys enjoy the rest of your weekend. But I think that's gonna be it, guys. Until next time, remember to keep on CADing, making, and all that good stuff. Yeah, I'll see you guys later. Bye.